Alright guys, welcome back. We're looking at the binomial theorem today. This is section 10.3.3. The binomial theorem can be used to write the expansion of a binomial expression in the form of a plus b to the nth power. In general, this looks like ncn times a to the n plus ncn minus 1 times a to the n minus 1 b plus ncn minus 2 times a to the n minus 2b to the second, so on and so forth. That's probably pretty confusing, so let's look at an example and see if we can figure this out. First thing I'm going to do is bring over Pascal's triangle here because I think that's going to be helpful for what we're looking at. And I'm going to just write out, our example down here is going to be an ab to the fourth or a plus b to the fourth expression. Let's take a look at that using the general expansion of the binomial theorem. So we're going to say a plus b raised to the fourth power. So following our pattern, our n is 4 here. So this is going to equal to 4c4 a to the n, which is a to the fourth. And they don't write this, but I like to write in b to the 0. And we'll see, I'll show you why in a second here. So the next one is going to be ncn minus 1, so it's going to be 4c3. And now what's going to happen is that the power on our a term is going to go down, and the power on our b term is going to go up. And we're going to continue this expansion until our a term gets to 0, and our b term gets to 4. So this becomes a to the third, b to the first. So our a went from 4 to 3, and our b went from 0 to 1. So for our next one, we had 4c3, we're going to do 4c2. This becomes a squared, b squared, 4c1. The a power keeps going down, so now we're at a to the first. The b power goes up to 3. And then finally 4c0. Now we're at a to the 0, b to the fourth, and we're done. So this is the general form of an expansion of a plus b to the fourth. So if I want to do it on a specific example, like down here when I have x plus 3y to the fourth, my x is my a term. So wherever there was an a in my general expansion, I can plug in x, and my b term was 3y. So maybe we'll just redo it ourselves here. So 4c4, I can put that in my calculator, and when I'm going to come up with 4c4, 4 choose 4, there's only one way to choose 4 items out of 4 items, so that's going to become 1. My a to the fourth is going to become x to the fourth. My b to the 0, I can write in 3y to the 0. Hopefully you realize that 3y to the 0 is 1, so it really kind of goes away. 4c3, again, I can punch that in my calculator and figure out that it's 4, or I can look over in my nifty-difty Pascal triangle here and look on the fourth row for n and see that the coefficient is going to be 4 for the second term. So 4c3 is 4. So a to the third becomes x to the third. B to the first becomes 3y to the first. 4c2, punch in your calculator, get 6, or look over here and see that our middle term is 6. 6 times x squared, 3y squared. 4c1 is going to be 4 right here. And this is going to be x to the first, 3y cubed. 4c0 is 1. A to the 0 is x to the 0. B to the fourth is 3y to the fourth. Let's give ourselves some more room. We'll go ahead and leave the final answer visible there, though, as we expand it. Just to check our work as we go along and make sure we do it all correctly. So keep simplifying this. 1 times x to the 4th times 1 is just going to be x to the 4th. 4 times x to the 3rd times 3y. Well, 4 times 3 is 12. That gives us x to the 3rd y. This is going to be 6 times 3 to the 2nd. So 6 times 9 is 54. X squared, y squared. Then we're going to have 4 times 3 to the 3rd. 3 to the 3rd is 27. So 27 times 4 is 108. X to the 1st, y to the 3rd. Then we have 1 times 1 times 3 to the 4th. Well, that's 3 times 3 times 3 times 3, which is 9 times 9, which is 81, y to the 4th. So there is our simplified, and we have this. Looks like we have the same answer down here. We sure do. Our simplified version of the problem that we started with, which was x plus 3y to the 4th. All right, guys. See you next time.